Algebra 2, this is Monday, October 22nd. If you don't have your calendar filled out, the information's here, or it will be on the board in my classroom. Today we're solving systems of linear equations, and the way it becomes a system is if you have two or more equations. So if you have two equations or more, it is a system. This is a system of equations. You have two lines on the graph. That's what makes it a system. The solution to a system of linear equations is any ordered pair that makes both equations within the system true. The point where the lines cross is the solution to that particular system of equation. So right here on this one, your solution is this point right here where those two lines are crossing. Your solution would be given as a point, so that's over what, about 2 and up about 2.5, so 2 and 2.5 would be your solution. There are three ways that you can describe the solution set. You can have consistent and independent. This is if your lines intersect or maybe cross. It's when you have one solution and the solution is at the point of intersection. When you're looking at the equation, it's going to have a different slope. Okay, your two equations are going to have different slopes. That means the lines are going to intersect or cross. You'll have one solution. That's where they cross. That's called consistent and independent. Consistent and dependent is when they're the same line. In other words, you have one line and then the other line's right on top of it. They're the same line. You have infinite solutions because your solution is where they touch, and they touch everywhere, also known as ARN. This is when you have the same equation, the totally same equation. Both the slope and the y-intercept are the same. And then the third possibility is that they be inconsistent. This is when your lines are parallel. They're never going to touch. Remember, your solution is where they touch. Parallel lines don't touch, therefore there is no solution. Can be written with 0 with a line through it. This is when they have the same slope. That's all that's the same, is the slope. So they can be consistent and independent, consistent and dependent, or inconsistent. So looking at my first graph here, these two lines are parallel. They're never going to touch. That means there is no solution, and they are inconsistent. The middle graph here, it's really dark because the second line went right on top of the first one. That means that your solution is ARN. They are consistent and dependent with a D because they depend on each other because they're the same line. Your third graph crosses once. That means that you have one solution where they cross, and we call this consistent and independent. Your calculator can help you find your solutions. Okay, if you want to use the table feature on your calculator, you start by getting y by itself in each equation. Put the equations in your calculator at y1 and y2. You go second graph to pull up your table. Find where y1 and y2 are the same. In other words, when you're looking at your table, you'll have x, y1, and y2. You go find where the numbers in y1 and y2 are the same. Then you use the x and the y value for your answer. So if you had something like this, okay, you see right there is where your y values are the same, but you use the x and the y. Your solution would be 1, 3. You can also use the graphing feature on your calculator to solve. Once again, you get y by itself for each equation. You put the equations in the calculator at y1 and y2. You go second calc, which is your trace button up high, number 5 for intersect. Remember, we want to know where these lines are crossing. It's going to ask first, you press enter. Second, press enter again. Guess, press enter again. So after you do second calc 5, it draws the lines. You do enter, 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 and it's going to give you the solution down at the bottom. Break-even point is actually a real-world application of this. It's the point where the two lines or the two equations are equal, which means your two lines intersect or cross. Break-even point is used in the business world. You have income, which is money you make, and expenses, money you spend. Your break-even point is when they are the same. You're not losing money, but you're not making money. So this would be where the two lines cross. Okay, number 1. On your notes for today, what it wanted us to do was tell if it was consistent and dependent, consistent and independent, or inconsistent. The first thing you're going to have to do is get y by itself. On your first equation, you need to move that 9x. So you end up with negative 6y is equal to negative 6 minus 9x. Divide everything by negative 6, and you get y is equal to positive 1 plus 9 divided by 6, which is 1.5 x. Now do the second equation. Same thing, get y by itself. So we're going to move that 6x. So you have negative 4y is equal to negative 4 minus 6x. Divide everything by negative 4. So y is equal to 1 plus 6 divided by 4 is 1.5x. You've got to compare these two equations you just got. Do you see that they're the same? They're identical. Okay? That means that they are going to be the same line. And we said that they're the same line means that they are consistent and dependent. Number 2. Start by getting y by itself. So we're going to move that x. Y is equal to 5 minus x. Second equation, we're actually going to move the 11 over the other way. 2x plus 11 equals y. You compare your two new equations. They're not the same equation. Look at your slope. Slope is the number in front of x. We have a 2, we have a negative 1. Not the same thing. That means that these lines are going to cross. If the lines cross, we call them consistent and independent. Number 3, get y by itself, so we're going to move that x. Y is equal to 3 minus x. Second equation, we're going to move that 6. 2x minus 6 equals negative 2y. Everything gets divided by negative 2. So that's going to be a negative x plus 3 equals y. Compare your new equations. We have a positive 3, a positive 3. We have a negative x and a negative x. Even though they're in a different order, their signs are the same, so these are the same equation. That means that they will be the same line, and so they are consistent and dependent. 4 and 5 want you to use the table on your calculator. You still have to start by getting y by itself. So move that x, and you have y is equal to 3 minus x. Move the 2x, and you have y is equal to negative 6 plus 2x. You're going to put this one in at y1 in your graphing calculator. You can put the other one in at y2. So you go to y1, you clear out what's there, and you say 3 minus x. You go to y2, clear it out, negative 6 plus 2x. You're going to do second table, pulls up your table. You're looking for where the y value is the same. Where you're going to find that on this table is going to be at this point that looks like this. The y's are both 0. You use the x and the y to write your answer. Your solution is 3, 0. Number 5, we're still using the table. You've still got to get y by itself. Move that x. Negative 2y is equal to 0 minus x is just negative x. Divide both sides by negative 2. Y is equal to, that's going to be a positive. You could just call that x over 2, and you put it in your calculator as a fraction. You could also call it 1/2 x. Either way. Other equation, move that x. Y is equal to 6 minus x. So go to y equal, clear it out. We have x divided by 2 for y1. We have 6 minus x for y2. Second graph to pull up your table, and where you finally find that they're the same, ends up looking like this. They're both 2. You use the x and the y, so 4, 2 is your solution. Number 6 and 7 want you to solve the system by graphing. You're still got to get y by itself. You're still going to use your calculator. So move this x, and you get y is equal to 2 minus x. Second equation, move the x, and you get negative 3y is equal to negative 6 minus x. Divide everything by a negative 3. You get y is equal to 2. That's going to be plus x divided by 3. And it's okay to leave it like that because you're just going to the calculator. You could also say 1/3 x. Go to y equal, clear it out. 2 minus x for y1. 2 plus x divided by 3 for y2. This time you're going to do second, calc, 5 for intercept. let it draw your lines, and then you're going to enter, enter, enter. And it's going to tell you that x equals 0, y equals 2. So 0, 2 is your solution. Okay, we've already done number 6, but I do want to tell you that sometimes you're going to get an error when you do your second Calc 5. Okay, if you get that error, it's one of two things. Either you need to go to zoom 0 for fit, because it just couldn't see where the lines were crossing each other, and then do your second Calc 5 all over again. Or it could be that your lines are parallel. If your lines are parallel, they're never going to cross. It can't find it. It's no solution. So go back and check your equation. If the slope is the same, but that's all, then they're going to be parallel. So check on that. Number 7, you got to get y by itself, so we're going to move that 15x. Negative 6y is equal to negative 15x. So you're going to divide everything by negative 6, and you get y is equal to 2.5x. Don't worry about it being a decimal, no big deal. Move your x on the second one, and you get negative 2y is equal to 10 minus 5x. Divide everything by negative 2. You'll get y is equal to negative 5 plus 2.5x. So you go to y equal, you clear it out. We have 2.5x, and we have negative 5 plus 2.5x. Second calc, number 5 for intersection, let it draw, enter, 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 and I'm getting the error. But if I will look, I have the same slope. They're not the same equation, but it's the same slope. There is no solution because these lines are parallel. Okay, this takes you to the assignment. And this was solving systems by graphing. If you have any questions, come in during speed and ask about it.